Alright YouTube, what's going on? It's Rewire STRIKE. I would like to talk about limits in this video, just the basic definitions, and I'm going to go over some examples of what these definitions are explaining, because this is pretty much all you really need to understand. They're very simple to understand, and I'm not going to start talking too much, but before I do, please like and subscribe. It lets me know what videos to make, how to, see what videos people really want to see, and I keep making them for y'all. So they're free, so hey, like and subscribe. So, alright, so the first thing I wanted to get involved with for definitions of a limit, the first definition is stated here, labeled by a 1. It says that the limit of f of x as x approaches a is equal to L. That is the whole definition of a limit. But we take it a step further in definition 2, which says that limit of f of x as x approaches a. Now this minus symbol here in the superscript is meaning from the left is equal to L, and I put a subscript here for meaning from the left, just so that way it pairs up with the A. It doesn't actually mean anything function-wise. But for the A on the superscript, it does. It means from the left in this situation. Now, for a limit of f of x is equal to L plus when x is approaching A from the right. Now, the plus here is the same thing as a minus, except minus is from the left, plus is from the right. But there's a condition with definition 2, and the condition is that L1 must equal, or excuse me, L minus should equal L plus, meaning that these two limits have to be equal. If they are not equal, then the definition is wrong. Okay, well, or it means that the limit doesn't exist if these two do not equal each other. So I'm going to give you a basic example here. I drew a basic graph, and I'm going to draw an f of x plot. Yeah, whatever. Okay, so using the first definition, you see that the limit of f of x, we're going to set a equal to 3. All right, so here's 3 here. We're going to write the limit of f of x as x approaches 3 is equal to, well, it's going to be this value here, which is 1. So that's the answer. It's that simple. It's not really that much to get. As you look at this graph, you see that it's continuous, meaning there's no sharp turns or holes. So that's pretty much it. But I'm going to take definition 2 into account, and I'm going to evaluate it from the left and the right hand side and try to see if the limit actually exists. So if we take the limit as x approaches 3 from the left of f of x is equal to, as we travel along here from the left, we see that it doesn't have to necessarily be the whole thing, it's just from the left. We see that it is equal to 1, and then I'm going to put a subscript here as a minus, and then we're going to do limit as x approaches 3 from the right of f of x. We're going to approach on the right, and that's equal to, yep, 1. And since 1 minus is equal to 1, that implies that our L is equal to 1. So there you go. That's definition 1 and definition 2 in the proper way. But I have a second example here, and the second example is the contradiction to this special part here for definition 2. So I pre-drew this graph here, and I'm going to set a equal to 2, right? So here's a, 2, and we're going to say the limit of f of x as x approaches 2 from the left, right? So here we're going to draw all along here up to the left. It's actually equal to 3. So we're going to put this 3 here because that's what it's equal to. And now we're going to evaluate a from the right hand side. So we're going to go all along here from the right, which is equal to 1. Okay, So we have a 1 here. Now note that 3 does not equal 1. So this implies that the limit does not exist. Okay? But I kind of wanted to take it a step further and identify this point here. Now, f of x, right, evaluated, I'm going to draw it this way. I'm going to say f of 2, right, actually does exist. It equals 2, right over here. So it does exist, right, the function, but the limit does not exist, which kind of goes back to what I said at the beginning, meaning that is discontinuous at a when a is equal to 2. And that's basically all you need to know about limits. I explained it in 5 minutes, under 6 minutes, and it's that simple to understand. Thank you guys. Like and subscribe.